Integration by substitution is basically the chain rule in reverse. What we're dealing with is a function of a function. Starting with this question straight away, we've got the integral of this, and as you can see in the denominator, we've got a function of a function. We've got the function of the function. So what we're going to do using substitution, we're going to substitute this function with u. So first step, I'm going to replace it. So I'm going to do the integral of 4x cubed over u to the power of 6 with respect to x. However, at this point, we're now integrating with respect to x rather than u, even though we've now introduced u. So to replace this dx, what we need to do is differentiate this u term here. So I'll have du by dx, which will become 4x cubed, and that's it. We now need to rearrange this so we have dx on a side on its own. So I'm going to multiply both sides by dx. So we'll have du equals 4x cubed dx, and then divide both sides by 4x cubed. So we'll have du over 4x cubed equals dx. So now that we know what dx is, we can replace this dx here. So we'll have the integral of 4x cubed over u to the power of a 6 multiplied by du over 4x cubed. I'm going to tidy this up a bit. So we'll have 4x cubed over 4x cubed u to the 6, all with respect to u. We can simplify this to become the integral of 1 over u to the 6 with respect to u. So now we're integrating all with respect to u. Now to make it easy to integrate, I'm going to move this u value to the top so it'll become a negative power. So the integral of u to the minus a 6 du. So it's still the exact same as above. Then we can integrate now, so we'll have equals. We'll add 1 to the power, so we'll have u to the power of 5 over 6 all over 5 over 6 plus c. Tidy this up a bit, so we'll have equals 6 over 5 lots of u to the 5 over 6 plus c. Now we've simplified it as much as we can go, what we need to do is substitute that u value back into place, giving us 6 over 5 lots of x to the 4 minus 1 all to the power of 5 over 6 plus c. And there's our answer. For this question, we've got u equals 4 minus x squared, so let's start writing this in. We've got x over the square root of u, or to write it nicer, u to the power of a half, all with respect to x. We need to replace dx with the du equivalent, so we'll differentiate u, which is du by dx, which equals minus 2x. Therefore, if we rearrange, du over minus 2x equals dx. So if we replace this over here, we'll have x over u to the half multiplied by 1 over minus 2x multiplied by du. I'm going to take the constant out, which is 1 over minus 2, so we'll have minus 1 over 2 integral x over x u to the half du. Simplify that, we'll have minus a half integral 1 over u to the half du. To make this look a bit nicer, we'll have minus a half integral u to the minus half du. Integrate it at this point, so we'll have equals minus a half lots of u to the half divided by a half, which is minus a half lots of 2u to the half, which then these two will cancel out, so it'll become minus u to the half plus c. Substituting our u value back in, so we'll have minus 4 minus x squared to the half plus c. Or some of you may have preferred to leave it as minus root 4 minus x squared plus c. Both are correct. Last question before I give you your first set of questions to try yourself. We've got this integral here. We've got the function in a function. So our u value will be 2 minus x squared. Substituting that u into this integral, so we'll have the integral of 3x root u dx. Now I don't like using square root notations in this. I find it much easier to write these in terms of powers. So I'll rewrite this as 3x u to the half dx. Now because we're changing this question from in terms of x to in terms of u, we need to change this dx because we need it in respect to u. So we'll take this u value here and we'll differentiate it. So du over dx equals minus 2x. Rearranging this to get dx on a side on its own, we'll divide both sides by minus 2x and multiply both sides by dx. So we'll have du over minus 2x equals dx. We can substitute in this now. So we've got the integral of 3x u to the half multiplied by 1 over minus 2x, all with respect to u. Tidying this up a bit, we'll have equals 3x, or minus 3x over 2x, multiplied by u to the half, all with respect to u. This x and this x here cancel out. So we'll have equals the integral of minus 3 over 2 u to the half du. I'm going to take that constant out of the integral, so we'll have equals minus 3 over 2 integral u to the half du. Integrate this now, so we'll have equals minus 3 over 2 lots of u to the 3 over 2 all over 3 over 2 plus c, which will give us minus 3 over 2 lots of 2/3 u to the 3 over 2 plus c. Simplifying down even more, this will just give us equals minus u to the 3 over 2 plus c. And finally, we substitute in our u value. So our final answer is equals minus 2 minus x squared to the power of 3 over 2 plus c. For the first set of questions, there are 5 for you to have a go with. Pause the video and resume when you're ready to see the answers. Here are the answers. To see them in full, check out the link below to the website which shows the answers written in full, and check out the video below which will go through them. Stepping it up a notch, we've got a slightly trickier question here which will become apparent in a moment. Well, firstly, we've got this function of a function. So we've got our u value, which is 3x plus 2. We'll rewrite our integral with our u value substituted in. We need to replace this dx with an equivalent du. So what we'll have to do is differentiate this u term here. So that will become du by dx equals 3. Rearrange to get dx on a side on its own. So we'll divide both sides by 3 and times both sides by dx. So we'll have du over 3 equals dx. We can replace this dx value now with du divided by 3. So we'll have the integral of x u to the 4 multiplied by 1/3 du. Because it's been multiplied by a constant, I'm going to move this outside of the integral. So we'll have 1/3 of x u to the 4 du. Now the problem is here, we're integrating with respect to u, however we've got an x term involved still. So we need to eliminate this x term and replace it with a u term equivalent. To do that, I'm going to look back at this u term here, and I'm going to rearrange it to get x on a side on its own. So we'll have u minus 2 equals 3x, and then u minus 2 over 3 equals x. So we've now got our x equivalent in terms of u. So we can replace this x value and get a third lots of u minus 2 over 3 lots of u to the 4 du. Now again, we've got another constant, which is a third, which we can multiply onto the outside. So we'll have a ninth lots of the integral u minus 2 multiplied by u to the 4, all with respect to u. Tidying this up again, I'm going to multiply this out. So we'll have a ninth lots of the integral u to the 5 minus 2u to the 4 with respect to u. We can integrate this now, so we'll have a ninth lots of u to the 6 over 6 minus 2u to the 5 over 5 plus c. I'm going to multiply that ninth through now, so we'll have equals u to the 6 over 54 minus 2u to the 5 over 45 plus c. And now finally we've integrated it and we've simplified it, so all that's left to do is to substitute those u values back in. Our u value being up here, so I'll have equals 3x plus 2 to the 6 all over 54 minus 2 lots of 3x plus 2 to the power 5 all over 45 plus c. And there's our final answer. We've substituted u in, we've replaced dx with the du equivalent, we've replaced the x with the u equivalent, we simplified it down and integrated obviously, and then at the very end we substituted our u value back in. This final question before your last set of your turn questions, we've got the integral of 1 over 4 minus root x, and we're going to let u equals 4 minus root x. So u is going to equal the whole of the denominator, so we'll have the integral of 1 over u with respect to x. Now we can't differentiate at this point as we're differentiating with respect to x, but we need to differentiate with respect to u. So we're going to differentiate this u here. I'm going to rewrite it, so we'll have u equals 4 minus x to the half. Differentiate it, which is du by dx, which equals minus a half x to the minus half. We need to rearrange it now so that dx is on a side on its own. I'll do it one step at a time, but firstly I'm just going to write it in a nicer format. So we'll have equals minus 1 over 2 lots of x to the half. Multiply both sides by dx, so we'll have du equals minus dx over 2x to the half. And multiply both sides by minus 2x to the half. So we'll have minus 2x to the half du equals dx. So we need to substitute this in now. So we'll have equals minus 2x to the half all over u with respect to u. I'm going to take out the numerical factor of 2, so it equals minus 2x to the half over u with respect to u. We still can't integrate because we've got this x value here and we're integrating with respect to u. So we need to replace this x value with the u equivalent, and to do that we'll use this u value here. So I'm going to add root x to both sides, so I'll have u plus root x equals 4. Take away u from both sides, so we'll have root x equals 4 minus u. Square both sides, so we'll have x equals 4 minus u all squared. We can substitute this into x now to give us minus 2 of the integral 4 minus u squared all to the half all over u with respect to u. You eagle-eyed mathematicians there may notice this square and square root will cancel each other out, as 2 to the power of a half will become 2 over 2, which becomes to the power of 1. So this nicely simplifies to minus 2 integral 4 minus u over u with respect to u. Because we've got two terms at the top here, 4 and minus u, I'm actually going to split this up. So we'll have equals minus 2 of the integral 4 over u minus u over u du, which simplifies even more to 4 over u minus 1 du. This makes it much nicer now to integrate. So now that we can integrate, we'll have equals minus 2 lots of, well, 4 over u, I've actually put the information up here of how it integrates. So this will actually become 4 ln u, and then we'll have minus u plus c. I'm actually going to multiply this minus 2 through now, so it equals minus 8 ln u minus 2u plus c. We can now substitute back in our u value, so we'll have minus 8 ln 4 minus root x minus 2 lots of 4 minus root x plus c. And there's your answer. If you really want to, you can expand this a little bit more, so you'll have minus 8 ln 4 minus root x minus 8 plus 2 root x plus c, and that'll be fine too. Two final questions for you to try now. If you want a challenge, the first question you can let u equals root 2x minus 1. The answers will be the same either way. Pause the video and resume when you're ready to see the answers. Again, for the full work-through set of answers, check out the link to our website below where you can find them there, or you can watch a video link at the end of this video and in the description below. Thanks for watching, feel free to check out the next video, like, subscribe and support the channel. Other than that, stay safe and healthy out there, and I'll see you in the next video.